Good morning, everyone. I am Anup Wadhwa from the Automation Industry Association, once again welcoming all of you to this wonderful series of seminars on advantage manufacturing. I am pleased to welcome our guest speakers for today, Ms. Uma Balakrishnan. Hi, Uma, welcome. Mr. Samir Gandhi from Omron Automation. Hi, Samir. Welcome to this panel. Professor Sunil Jha from IIT Delhi and also Director of the Foundation for Smart Manufacturing. Good to have you with us, Dr. Jha.
Yeah, good morning, sir.
So today I'm going to start by once again defining the context of our webinar. We've been doing this series in the light of the disruption of COVID and the preparedness of the industry to go back, reboot, and then get on with production. So in that context, rebooting as well as taking advantage of disruption is what the context is. And more recently, the focus is now shifting to self-reliance. As the Prime Minister has said, what we cannot control is the virus, but what we can control is taking charge of ownership. So that is the backdrop. We are bringing in and these expert speakers are definitely going to tell you what are the possibilities of automation, how you can drive your processes, how you can drive technology on the shop floor, how it's going to relate to your overall ability is the key question. And Dr. Jha and Samir and Uma are all technology experts, but you are the experts on your business. So collectively, we will be doing the knowledge sharing. Collectively, we'll be hand-holding and building a self-reliant ecosystem. So that's going to be the focus of this series of seminars. Can I have my slide? Yeah, so this is just the shift in mindset which we are now hoping is started happening in the country, that the firms are now going to take charge and redefine themselves. And this redefinition, most of the pundits say, should really happen at three levels. One is the processes, the physical processes they deploy, the business processes they deploy. Second, the centerpiece, which is technology. That is the focus of AIA and the Foundation for Smart Manufacturing, and also the focus of our sessions. So we will be focusing on the automation technology, the connectivity, and the intelligence, primarily related to shop floor. That's the cornerstone which we support. But the other third pillar is the organization, which is the people related, the talent readiness, the structures and management. So when firms redefine themselves, we hope that they will take all these three pillars and from there they will then drive the technology. So that's going to be the theme of not only today's session, but all our future sessions. Now I have the pleasure of introducing the speakers. But before that, just a little message for the audience. We will invite you to participate wholeheartedly in today's session. Our session will have two polls. You will be able to participate in the poll, and then there will be question answers. And in between, if the speakers choose to engage with you, they will have the option to do that. So stay tuned in till 12:30, and we hope to wrap up the session by then. Well, that's a brief introduction about myself. Can we move on to the next speakers? I'd like to introduce these other guests today. Yes. So Uma Balakrishnan is an engineering graduate with an MBA, a very high energy person, and she has been engaged not only in starting her own venture, which is Accent Automation, but she's also engaged with non-profit industry professional bodies like ISA, and of course our own Automation Industry Association, where currently she holds the position of vice president. In her various capacities with ISA, she's been the president and the secretary at the regional level, and also the secretary at the District 14 Asia Pac level. So she has been working in driving new thinking and collaborative initiatives across the ecosystem. Uma is also very passionate about women development, and she's the first chairwoman of the Karnataka region, which she launched a couple of years back. And I know her personally. She spends a lot of time supporting leadership programs for girl children. And another passion of hers is inducting more and women energy into the factory floors. So that's Uma Balakrishnan for you, and she'll be our opening speaker. Welcome, Uma, once again. Then we have our second speaker, Mr. Samir Gandhi. Mr. Samir Gandhi brings a huge experience of over 30 years in the manufacturing and automation realm. Endowed with an agile personality and multifaceted skill set, he is very passionately working to establish Omron as a comprehensive automation partner in India, providing end-to-end solutions, particularly for the discrete manufacturing industry. Today's session is also going to focus predominantly on discrete manufacturing. Prior to working with Omron, he has served with ABB, his previous title there being the Vice President of Strategic Account. And he has had experience in minerals and cement, pulp, paper, and robotics. So extremely multifaceted technology expert. Welcome, Mr. Gandhi, once again. My third guest is Professor Sunil Jha. Today, his role is not going to be so much of a speaker, but he'll be the what should I call him? The wisdom person. He's going to be taking a very balanced view of what the speakers present, and also he's very much glued to what India's industry requires, particularly at the MSME level. So he's going to balance out the discussion, and I'll be inviting him for some time, after every topic has been spoken about. Professor Jha did his PhD in manufacturing science from IIT Kanpur, and he has been engaged in teaching and research on manufacturing processes, computer-aided manufacturing, and industrial automation for over a decade. And he has developed some very unconventional super finishing processes and filed 6 patents, and a few of them have also been successfully commercialized. Before joining IIT Delhi, he has worked with Tata Motors in the area of CAD/CAM, and he was engaged closely in digitization of engine components and foundry tooling development. Currently, in his capacity as a professor of IIT, he holds the post of director of the Foundation for Smart Manufacturing, which is a joint venture of IIT Delhi and AIA. And so most of his conversations today will really weave around putting the whole story together as if, we are all on the same side. Welcome, Dr. Jha, and pleasure to working with you in an ongoing manner. Okay, great. So we've had the introductions, and we are now going to head straight into the first topic, which is the topic on driving certainty. and this will be presented by Uma Balakrishnan. So, just mm, Uma, I'd like to ask you, is automation a de facto thing which now business needs to take for granted, that it's common sense, it needs to be applied? Or do you think, there is a nuanced understanding and there are specific roles for automation? So, just take us through some of those choices as you present today's topic. Over to you, Uma.
Yeah, thank you, Anup. Thank you to all the attendees for taking time to attend this session, and to the co-panelists, Professor Jha and Samir Gandhi. Anup, the question you have asked is, is automation something that you need to apply, use common sense? I think if we can renew our perception of what is automation, I think that would help in a time like this, because we always associate that as an English word for a robotic or a HMI or something. And I think some part of what I'm going to share this morning is going to probably cover some dimensions of that. If we can apply what is basic common sense in any business, we are focused this morning on non-heavy asset industry. So I would use discrete, but it's not for an oil and gas or petroleum or very asset heavy industries, continuous industries. Outside of that, I think whatever we are sharing is going to be horizontal and balanced across that. I think if we can apply a common sense from, it's not that people didn't have it before, I think that would be wrong to say that. But if we can go back to the first principles of fundamentals and say, what are we accomplishing in manufacturing? And to accomplish those, how can I use the tools, rather than getting overwhelmed with technology and saying, this technology does this, so I need. So many times we get carried away by the name of a SCADA or a HMI or an MES or a PLM. I think if we can just shed the names aside and look at what do we want to accomplish in the shop floor, and what are those tools that I can bring together. Very akin to manufacturing. I want to manufacture something. I have a manufacturing process to produce a product. Similarly, if you can have a systems engineering process, which can blend software, hardware, all of that to come together to accomplish a business outcome, like a product output, I think the goal would be accomplished. And that's the tone for the session this morning. Can I begin, Anup, with? Yeah, I guess that's an S. So, first of all, trust all of you are safe. And one of the questions asked in the mock this morning is, hey, you seem to be in the office. The building looks, your background looks like office. Yes, I think with the easing of lockdown, there's a slow opening of different geographies. And so the question now is, amidst all these dynamic things where you don't even know which day, what bus will come, whether the truck will flow, amongst all of these, how do we manage and how do we ultimately produce what we want to produce? So one is, it was not that there was there were no demand changes earlier, I think, but they were driven by business dynamics that the demands were changing, but now it's amplified more by the pandemic effect. Pandemic has also brought another unique dimension to it of newer constraints. We always knew constraints of, I have only so much of resources, how do I manage? But then you have new rules. We used to have regulatory rules in pharmaceutical and other things, but now we are talking about a horizontal regulatory, which is everybody should stand within a 6-meter distance. Now, if your manufacturing assembly line has got an operation which has got adjacency, how does one deal with this constraint and do? So I think we are talking about newer dimensions, and the traditional wisdom of I have done it before, I know it, no longer exists for any industry, any professional. So it's an adventurous time. It's going to be turbulent, but I think we can steer the boat, and that's what we're going to cover in the sessions. Simple things which everybody understand are financial risk, liquidity and capital. There's constraint, both working capital and capital investments. Strain supply chain, either we by our production are causing the strain in the supply chain, or our supply chain is giving. You could be in any part of the chain. And work for adoption. I think, are we looking at automation? I think it's a word used. Are we going to do robotics? I think that subsequent speaker is going to speak about it. If you do that, what is a workforce adaptation, or what are the things that one needs to do? Let's look at the next few things. We are looking at factory or manufacturing a little horizontal here. So the picture is just symbiotic for what is done. It's not specific for an industry. So you basically have incoming material and you do a set of processes, whatever they are. It could have batch and packing and whatever are those. And then you have finished goods going out of it. So if this is the shift, this is the process which is happening, what are the fundamental levers that we use for operations? I think everybody is familiar with this. It's material, machine, man, and if you look at it, method, we have made it a little amorphous because method, we want to cover here both the physical manufacturing processes and method, and the business flow and information flow, which Anup covered in his starting deck. We are using method as a synonym for both the aspects here. So if these are the levers that we are using for our operations, how does it manifest? All of us know that you use material, then you're looking at ordering, planning, what do we do? Look at the manifestation. If you're looking at machine, how do I use that as a lever for me? I'm looking at how will I plan my production, what kind of schedules. We'll get into more details. If you're looking at man, we are looking at it from multiple purposes: skilling, repurposing. And methods, what we mean is recon, which means today you see automotive plants making medical equipments, masks. How does somebody take a facility and completely repurpose or reconfigure them to do something completely new in the new aspect? So let's walk through some of these and look at the idea. When I walk through these slides, I think I'm going to ask a couple of questions that you can put it on as response on your Q&A, and where you closest relate in your business. Is when you look at material, we are looking at multiple things. You would have had a certain minimum order quantity earlier. You would have had lead time of a certain kind. All of these are going to be recalibrated. They no longer are going to remain the same. But your entire transaction system and your workflow systems are programmed for a set of parameters which are set in a defined way. So how does one manage the business today when each of these is going to change? Cost of material, what you take to source something is going to become completely different. Actual consumption, you might have been adopting a certain consumption in a earlier fashion, which you have past data, they might be no longer relevant. So material, if you look at it, there are multiple parameters around which everything gets redefined. If you look at it from a machine side, this is just to trigger some thoughts so that you can look at what happens in your business or particular factory. If you look at machine, it's about availability. Earlier, it would have been that you're maxing throughput because everything is set. But today you might have availability at its highest, but demand might be less. So how do you still schedule and manage it? Second, if you have a certain setup change over time that your manufacturing processes are lost, how can you change those sequences so that you can maximize output? So that's again, none of your earlier parameterizations are going to work. Maintenance. Now machines, we hear of situations which have happened, unfortunate situations in the chemical plants because of long shutdowns and opening up. How would you do your maintenance now for the first few months, and later is going to completely change? Product variance. I think the demand for the products, what one looked at earlier, is there going to be a new product introduction now, or is somebody that depends on each company's strategy. So what really is a challenge here is when you have all of these, we are pegging it around vision because they all relate around the production closely. You're looking at a different kind of planning, you're looking at a different kind of scheduling, and you're also looking at how can I get real-time information that I can calibrate and start doing automatic changes that improves my production flow. We looked at man, we looked at machine. Let's look at the next one, which is material and machine. Let's look at man, the most complex one on this. I think there are multiple ways you could skill, reskill. There are work instructions. We have intentionally refrained from any technology in the entire presentation so that people can correlate it with basic logic and apply to it. So you might want to skill them or repurpose them. So if a particular process is going to be automated, you might want to repurpose the person to do something else. So how can you make people instead of bringing technology to be people to become technology literate, can we make technology to be people literate? So we show tools like these, which you can see any cognitive ability of an average person with no additional skills will be able. So can this be a way of managing man change in this scenario? The last one is the method. We already spoke about it being complex. Method has got two dimensions to it. One is like you see an entire flow here, which is digitally modeled here. If I want to make a completely different product around the line, like what some of these facilities quickly turned around, you're fundamentally making a horizontal change in the method. You could have things like, no, I'm not making major changes, but a few of things which I'm doing, I will do slightly differently, which means you only apply the method on a certain way you're handling the material, or it could be the certain way you're doing your machines, which we covered in the earlier slides, or it could be in a way you addressed man repurposing, or it could be a mix of getting material, man and machine and recreating the methods from the business flow that empowers in. I have a quick question for all of you. What in your perspective as a day-to-day challenge now, if you see between man, material, machine and method constraint, which do you think is on top of your mind as the one that you see it? If you can quickly put it on your Q&A as chat, it would give us an... I'm going to pause for a couple of minutes so I can see. It's not that we are going to respond to a specific question, but I think we'll get an idea of what's on top of the mind of everybody, and I can just share if it's, then you know it's not the problem you alone are facing, but everybody is facing. I got one, but if you can quickly put this, because this is absolutely private, this data is not going anywhere. I'm sure AI would. Yeah, I see man and method, I see man. So I don't know how many audience are there, but just to quickly get an idea of it. Okay, so man seems to be on. Okay, so let's look at, okay, most of them, is there anybody who machine reliability, all four in balance? Yeah, so we are seeing it's a combination of many things. Somebody has written, how do I automate the method, which means you're reconfiguring the method. So if we, okay, thank you all for sharing that. It just gives an idea to say, man seems to be on top of the most people who responded. So it can be an implication of, do I want to reskill or do I want to automate? But I think the main idea is how do we recalibrate the existing resources and get going to the next level. Can we move to the next slide? So let's come to the next part, I think the second half of the presentation, and I'll go through that. Basically, we looked at man-machine. Let's set that aside and look at what really happens on a shop floor on a daily basis from executives, and you have a senior management, somebody asking you questions or asking for reports. I think there are two fundamental things. One is to have visibility on what's happening on the production. Okay. And the second is based on which somebody takes an informed decision. The key here is the word informed, because informed means you're not shooting in the dark. You have certain information and you take a call based on that with human judgment around. We are not talking about advanced, fully automated lines which configure themselves. We're talking about still in India about where human take decision based on this. So if you look at it, both reinforces other. You see something, you see it on the shop floor, you take a decision, then you see based on that informed decision what's the impact on the shop floor, and you keep. So it's an iterative process. So if these are the two facets of it, let's look at what do we see in production visibility. The typical thing which comes in the mind of anybody when we speak production visibility is, oh, I'm talking about a SCADA screen, or oh, I'm talking about an MES, or I'm talking about ERP dashboard. No, here we are talking about visibility of anything. It's like when you drive a car, you have a set of things. It might be coming from the engine, it might be coming from the wheel, but it comes holistically that you're able to drive the vehicle. So we're talking something like that. So if you look at this prop on the screen here, You could see the entire process, which is the line. You could look at throughput. You could look at things. So basically, what aids, and to answer Anup's question in the beginning, what he asked is, can we get whatever we need to come together on one visible way that I can see, which allows me to understand what is happening here. Here I want to pause to make a very important observation. Out of various interactions we have had, and I've been in the industry to close to 34, 35 years now, all the time the question is about connectivity, intelligence, data, and then we want to put it over the entire plant. And many times we forget that the cost of the information that you take, so you get an information, let's say speed of something. If something you will do with that information is not more valuable than the cost of getting that information, that the speed of it, then I don't think any company should invest in getting that information. So one simple way to do cost benefit analysis, what information is important for me? Okay, not what information can I get from the system. You do the reverse. What information is important for me to know how the business is running? And therefore, what if I get? If we can just pivot the thing from because most questions come, I have this PLC, what gateway? And it's immaterial. You might not even need a gateway. You just need a start stop to know whether that machine is running or not. So whether the cost of what you do with that information, the benefit of what you do with the information should be certainly more than the cost it takes to get that information. So our recommendation would be, don't look at digitizing everything, or I want to get all the information, look at it. That's one way. The second is, doesn't matter where the information is, ERP, wherever it is, or even if it's manual, can you get it in a way that you're able to, for example, if you see on this particular one, you can see on the right, it shows the past few events which has happened across the spectrum. You can see somewhere else what's the variant happening. Somewhere else on the top, you can see a forecast. And if you move a little deeper, might be you want to get just to know about one unit, nothing more. So you decide based on your application and your business needs there, what really you want to see and move forward on it. The other part is, when we get information, they always get aggregated and put into blocks, so this is a typical block of how I see the data. I know throughput, I know breakdowns, I know this, I know what's the planned versus thing, what's the performance. I'm sure all of the organizations have reports, but these are on past data. So one of the things is, how relevant is the past data to your decision making will depend on the process or the business that you do. For example, let's take the COVID situation. No country has been able to say, this is my past data, because it's unfurling on a daily basis and we are adapting newer strategies. We are seeing another country and predicting this is how it will be. So when it's that uncertain, sometimes past data is not relevant. And you might want to say, I will work on current data and work in real time and use past data only where it is relevant. I won't do it as an uniform. So your reports, your reviews, what data you will do, I think will certainly get reconfigured in this period, either through your management top down or bottom up, on how you will do these things. It's a very, very important dimension to look at. We've looked at visibility. We spoke about two things before I move to the next slide. We spoke about two parts in it. One was production visibility, and I spoke about another thing. I just want to know if the audience remember what that was. Can you just put on the Q&A as a response? Probably it's an answer, not a question. What was the other thing that we wrote on the top before I move to the next slide? We said two things reinforces each other. One is you do, can I get some responses on that? Somebody says voice is not audible. Yeah, so I guess from our make the informed decisions. Thank you so much for responding. So let's look at the other dimension of it. We're talking about how do you take informed decisions, right? Informed decisions are, I have a data, I want to analyze it, and I want to make sure what could be the outcome. On a humorous front, it could be like I go to a shop and I buy a dress and there are different sizes. You put two sizes and say, hey, It's neither this nor this, but I'm going to pick something in between because that's my best fit compared to what is the choices available. Very similarly, when you want to look at what if scenarios, you're not going to get a perfect answer, but you might get a band and say, if I take a call within that band, I have a better chance of getting a better output. So one is looking at what if scenarios. You can look at it from multiple dimensions. You can look at it from material impact. You can look at it from people impact. You can look at it from maintenance. That is, I'm looking at machine that impact. You can look at multiple dimensions of it. I'll walk through one of them just to give a perception, a feel of how that happens. So for example, if you're look at this interplay between method, man, and machine. So we are talking about, if I have this changeover, I do it in this way, you could analyze and get an output. Or if I have this operator assigned here, or this operator regrouped for 2 stations, you could take an output and look at it. If you're looking at machine, you could say, I'm putting this machine available at this time, but I think it's got a lower reliability, so I'm going to change it. You can do analysis that way and get an output for decision making. Other one is an integrated one, like for example, something like this, where I have a certain lot to be delivered and I have constraints on labor or whatever the COVID situation has brought in, or my material, my supply chain is hurt, I have only this. Then what I could do is run the what if to make a mix of all of these and say, okay, to produce this output of this kind, if I run with my current constraints, what are my outputs? You can see 2 scenarios here. Either I miss the due date and I give it as one set, or I distribute it and get it, I miss the quantity, but I commit to the due date. So there are what if scenarios like this that you can assess and then take a call, and you will build better customer intimacy with this knowledge. Your customer is going to appreciate that you're doing your best on all of these. So we're coming to the last leg of the presentation when we go to this, and I have a quick poll that we want to run before we start that. We spoke about production, visibility and thing, and we spoke about driving certainty. I said that's the goal. So if you were to look at one thing that you would want to drive for sure, because there's a trade-off, you want a better throughput, you're going to have a higher throughput, you might be making a trade-off on the tolerances, or on your material, you might be buying it at a higher cost because you want to ensure you produce it on that day. So you're always making choices amongst this. So if you were to drive certainty on a parameter, which is, I'm going to benchmark my quality, I want to assure that it is at that perfection and I don't mind a trade-off, or it's on cost, or it's on throughput, there's a quick poll that we want you to respond on. What would you choose? This is for all the audience to quickly respond. This is an AIA triggered one on the poll that we speak about it. So the more the votes, the percentages, otherwise with lesser skew, it becomes more. I'm not going to speak till the, if the speaking is distracting, I will be silent for a minute. You'll have to treat it something like Super Singer or some TV audience poll. So if you can get more out of it, I think we get an idea out of it. I'm also going to lead with taking one scenario which seems to be the most popular and walk it through, and then we sign off. I think I have another 8 minutes as a part of the session. I should be able to wind up a little earlier too. Thank you for those who have voted, and a kind request for others to quickly put in. So we've got about 35, 45. Thank you. So you can still do it. I think you can continue it, but I'm just going to show the, can you do the show results too? So if you see the, I've blessed it, right? If you see it, I think its majority is coming between, it's between cost and throughput, I think, from a thing. I think the idea of quality is not that people don't want to trade off. I believe they already hold it at a certain baseline. So let's look at how does this, Hari, next slide, please. So if we look at cost, right, let me take a scenario to explain on this. See, one way of, let's look at cost. Cost has various components based on multiple things you're doing. One could be an inventory holding cost, right? So if you are buying and sourcing your inventory for your production in some way, can we dynamically, the scene what you see on the screen shows how can I, it basically uses two levers here, material and man. A method or machine is not impacted in this particular case. We're talking about taking the inventory, looking at MOQ, looking at lead time, and apart from your ERP, MRP, what it does, these would help you do quicker, shorter runs to say amongst this, you give a certain constraint saying you can change each of those parameters like MOQ or lead time or all of that, run constraints against each of that saying if I'm going to have this much as my ordering quantity, minimum ordering quantity on my bin level, how do I change? And based on that, you can run this analysis. It gives you a changing demand and it will assure you on what deliveries you can make. If you can renegotiate with your customers for slightly optimized delivery, then that's one way of which you can handle. In this case, we are looking at cost through material and man as an engagement. I'm going to skip the quality because quality was a thing. I'll be briefer in that. In quality, we're looking at this particular case, use the word traceability, but it's a risk. And so, because what material you get can, if it's rejected, can be a disruption in the supply chain. So can we look at critical parameters? This particular one is, let's say, you don't need all the process parameters. You need one or two critical process parameters in your quality system, which guarantees the product is good, which you can dovetail to your supply chain. Can we put some slick automation there that ensures here it's based on the number of shots in the mold which is done. This automates that process and ensures that quality overrides everything else and the production stops if that is violated. So it depends on the priority somebody sets on the business. Third, if you're looking at throughput, there's multiple ways we can achieve efficiency on throughput. When we talk about throughput, we are talking about material, machine, man, and methods, all of them coming together. Put some snaps out of this. It could be like I am producing this. This is for a cable manufacturer where they had different thicknesses, and the set points had to be changed each time, and the operator was obviously diffusing time doing that. This ended up in buffer material coming in WIP. So what was done here to increase the throughput was the set points were automated based on the line measurements automatically so that the man interference is influence on that is less. So it ensured the throughput went up because buffers of stock were not left lying in between. It could be in another case of power where they are looking at optimizing power cost. So ensuring that cost of product doesn't go very high. So typically when we speak about that, you always do energy management systems as a centralized one. Here they went from the process side and associated every process with energy and realized that if they can recalibrate their energy systems, their compressor management and few others based on this, you get a better efficiency coming out of it in production without compromise on throughput. These are few scenarios that I thought we could share with you. But obviously, these are the scenarios we see. What is the scenario in your mind? And I think that's something you can share on the Q&A port. You could write some of these scenarios that might help AIA-FSM aggregate that, and we can sort of value add somewhere to say what could be those things that you could do. I mean, there are a million contexts around which, and with all your experiences, I'm sure it's in. So that's it from my side, I think. And over to you, Anup.
Thanks, Uma. I think that was really mind-opening, if not mind-blowing. I would now turn to Dr. Jha. Dr. Jha, how do you see the triad of quality, cost, and throughput
Yeah,
again
if you see, yeah.
support each other.
So, in fact, what I have seen the results that has been displayed on the screen by the audience, I think it's a good balance that people have shown that the cost and throughput are the critical one, and I really found that the most important one we ignored is the quality part. We are not thinking them all connected. So, in fact, if you see that though it's a business, so ultimate outcome would be the profit and the margin that is coming out of the, so it's all about the economics part, but how they are coming out. So all these three are linked together. If you see that when we talk about the improvements, improvement will always come at certain cost, and if this cost is being considered, and with the quality by increasing throughput, if I'm able to make a profit, I think that's a point we should look into. So my point is, my suggestion or recommendation is that we should not see them in isolation. These are all to be seen in totality. So how it's finally makes a business economics for you, how it's going to make impact, I think that's the way we can make our decisions. Over to you, Anu.
Very nicely put, Dr. Jha. I think you wrapped it. It's all integrated and it's all wholesome. So that's nice to hear. Okay, now we've had a look at the role of software or information, but now let me get back to another favorite topic these days, which is the definition of new normal. And we are saying that the new normal will be based on reduced manpower, though there is some talk also that some factories have been allowed to go with 100%. So we don't know what's going to be the final standing on this. But apart from software solutions, I would now like to turn to other technologies, and that's where I bring in Mr. Samir Gandhi. Mr. Gandhi, which are some of the other technologies for shop floors which can create flexibility in the execution and are also affordable and probably within the range of SMEs to adopt? Mr. Gandhi, over to you.
Yeah. Thank you, Anupji. Thank you for asking that question. First of all, I would like to thank all the attendees for this webinar. I also want to thank all my co-panelists, Dr. Jha and Ms. Uma, for giving their insights that they have done already. And I also want to thank the FSM and AIA for organizing this series. So I think this is, I'm sure a lot of our industry fraternity is finding this very useful. So back to your question, Anupji, I think from a technology point of view, we can have many technologies. But I think before I answer that question, I also want to talk about the fact that you mentioned the new normal, right? So the way I think we all see is the COVID has disrupted everything. I think my previous panelist, Uma, also spoke about the fact that earlier the changes were happening in a kind of a more gradual fashion. There were business changes that were happening, and it took some time for the change to come in. But now we are in a situation with COVID that we have seen that there has been a very sudden disruption, a very sudden change. And our normal has kind of shifted. So I think many technologies, especially automation, has a major role to help industries adopt to this new normal. I would say, actually go to the extent of saying these technologies have the give the opportunity for the industry to actually take opportunity of the new normal, to leverage the new normal for growth. And one of the key factors that could help, one of the key technologies that could help is actually robotics. So robots have been around now for decades, okay, a couple of decades already. and I think their usage in Indian industry has also been growing. But I would want to talk about today how this technology, which is becoming more and more affordable, affordability is of course very important, and the ROIs are coming faster and faster, quicker and quicker. How this technology can be easily adopted in parts by MSMEs, and how this can help overcome some of the immediate challenges that the MSMEs are facing, as well as how could they actually take opportunity or leverage this as an opportunity to leapfrog, especially for the Indian MSME sector, using robots as an opportunity to leapfrog in the post-COVID world. So let me begin my presentation. So of course, as we all discuss, post-COVID world is the new normal. So what's the new normal that we are talking about? So the way I see it, there are, of course, new challenges for the industry. That's the new normal. And one of the challenges that we all keep discussing and talking about is social distancing on the shop floor. It's easier probably to do a social distancing aspect in the office, but how do you do on the shop floor when maybe parts of the shop floor were designed for 2 people or 3 people to work together? They were not designed to keep, they were designed optimally for the machines and maybe material movement between the machines. So they were necessarily kept close together to save time, not actually designed to keep spacing between people. But that's the new normal. And even if 100% industry is being, 100% manpower is being allowed on the industry floors, I believe social distancing is going to remain for some time with us, uh, because the coronavirus is kind of not going away anywhere soon. The other challenge, ironically for India, is I think the unreliable availability of skilled manpower or sufficient manpower. I say this ironical because the Indian industry has been used to, seeing manpower as something that was a given. You could find any number of people. Yeah, maybe there were some skill challenges, but basically people were available for the Indian industry, even for the MSME sector. They could attract fairly good resource. But I think now, with this kind of a COVID situation, the way we have seen people moving away from large industrial centers, poor people moving back to their hometowns, um, and it's not very certain of when somebody is going to come back. What is also not kind of certain today is the guy going to come tomorrow or not? So there is I would say, a kind of an unreliability. I don't like to use the word unreliable, but an unreliability is kind of coming in terms of availability of people here. And I think that is one big challenge that the Indian industry has to prepare for. And I think it's my assessment, my understanding, that the MSME sector will have to actually bear a bigger brunt, a bigger share of this of this specific challenge. The third challenge that I want to really talk about is uncertain market dynamics. So I think what I really mean here is fairly easy to understand. I think earlier, there was a lot of certainty when we spoke about market dynamics. For automotive industry is likely to grow 5% next year, or it's going to degrow 10% next year. But now, I don't think any one of us is actually sure what's going to happen to the automotive industry. Just as an example, I mean, this could apply to many other industries, but we're not sure. Some people within the automotive industry are predicting a return to small cars, and they expect the market to actually grow. Whereas other people are predicting, no, this is not going to happen. People will not buy cars. Maybe they will buy two-wheelers. Or somebody is saying, no, maybe they don't want to go anywhere, so they don't want to buy even two-wheelers. And all kind of alphabets are being, thrown around in terms of recovery. Somebody saying V, somebody saying L, somebody saying W. I think we have run out of 26 characters there. But whatever it is, I think one thing is for sure, the market dynamics are changing tremendously. We are looking at a high volatility on market dynamics. Nothing is certain anymore. And what it means to an MSME industry is that we are looking at high mix, low volume kind of a setup. You require high flexibility. You are making a product today, you think you have a production for the next 1 week, but after a week you might have to change what you're doing. You might have to change the product dimension, the the entire setup changes, the assembly of the product changes, god knows what. Maybe you are supplying to a two-wheeler manufacturer, now suddenly you need to supply to an aerospace guy, and after that maybe you maybe get an order from a pharmaceutical company. So that the whole dynamics is kind of going to change and require high flexibility. But that's enough about challenges. uh, I think also we must not lose sight and get all pessimistic. We must not lose sight about the opportunities. And I think there's a huge, big opportunity waiting for the Indian industry, specifically the MSMEs. And that is the global supply chains are resetting and realigning. A lot of supply chains are coming. There are a lot of terms being thrown around: near shoring, you know, kind of scenario, de-risking by not keeping everything in one country, and so on and so forth. But one thing is for sure, I think the supply chains globally will reset. A lot of opportunities will move out of China, come into countries, especially countries like India. We stand on the cusp of an opportunity to leapfrog if we can grab this opportunity. And how do we do it? I think four key important aspects for us to be able to grab this opportunity. We have to win by quality, by consistency, by reliability, and by hygiene. Let me try and explain this towards the end of my presentation. So I'm going to basically, the next few slides, I'm going to talk about each of these challenges, how robots can help overcome these challenges, plus how robots can actually help grab this opportunity. So moving on, so I think it's the robots to the rescue as far as the Indian industry is concerned. So we are at an inflection point here. This is the point, I think, where the Indian industry the adoption of robotics in Indian industry is likely to grow, and actually something it's like going to become the technology that will help the Indian industry grow by leaps and bounds. Okay, before I actually get into the challenges and the opportunities and discuss more, I just want to talk about two slides where I just want to set the basics in place. So for many of the attendees here, we have some vision about robots around, but I just wanted to bring up an image, a slide of what exactly are the common industrial robots. So let me try and start my point here. Yeah, so of course we can divide them into three basic categories: the fixed robots, the cobots, and the AMR. The fixed robots, we actually have about three variants. There is a parallel robot, there is a SCARA, and then there is a Viper, a six-axis articulated robot. This, of course, is the most commonly used one in the Indian industry, and can be used for a variety of applications. The other kind of robot which is finding a lot of adoption today is the cobot. And when we talk about cobot, we are basically talking about collaborative robots. And these are the kind of robots that can actually work together with humans in a kind of a more safe environment. So the basic difference, if I was to say, between fixed robots and cobots is that fixed robots require some kind of physical barriers or fencing for them to be able to work together, whereas the cobots may not, I'm using the word may not require a physical fencing for some application needs. And then, of course, we have the third variety here, which is called the AMR, which is the autonomous mobile robot. And this is basically a mobile device which moves on the shop floor, It can find its own path, guide its own way, and has on-built safety sensors, so it knows how to work around safely amongst people and moving or dynamic objects. I want to kind of emphasize that a lot of these slides that you show, of course, talk about Omron stuff, Omron products, but a lot of this is actually available and is brand agnostic. So it's not necessarily only something that is coming from Omron. The other thing I wanted to set the basics in place is about robot cells. I just want to bring in some terms here because I will be using them at a later date. So very often it's kind of, we find people talking about, okay, I'm going to replace an operator with a robot. I just need to buy a robot. But actually that's not enough. That's hardly enough. To convert a manual cell to an automated robot cell, you need, of course, the robot, but you also need the tooling, which is also called the gripper sometimes, the various sensors that will help guide the robot, as well as a part feeding device, which could be conveyors and so on and so forth. Plus, you might even need a safety enclosure. So that's how you actually end up building a robot cell. So there are essential components that go towards building a robot cell and need to be factored in when we are discussing about converting a simple manual operator cell to a robotic cell. Okay, so let me move on and let's talk about the first challenge, which is the social distancing on the shop floor. So what it means is, here's an image of a typical shop floor. Okay, and as you can imagine, there's enough social distancing here, about 4 meters, and there's enough here about 6 meters. So this looks like a very happy place, at least for these guys. But how about these people? There are two operators working together. It's not a work that can really be done by one operator. So you need two people there. How about here? Again, you can see two people working together for quality inspection. How about here? All of this are situations that are actually practically happening on shop floors around the world today. How do you get social distancing here? And I think this is where cobots, especially and AMRs, can help reduce worker density on the shop floor. How? So, for example, you could replace here one worker with a cobot. So a cobot and a worker work together, and of course you can achieve social distancing, right? The other option is using an AMR. Sorry, I pressed the wrong key. Using an AMR, you could automate material delivery on the shop floor, thus eliminating the need for people to actually be on the shop floor. So that's how these two devices can actually help reduce worker density on the shop floor. So let me move on to explain also a little bit about how can actually these devices work safely with humans. So cobots, of course, are smart. They have built-in intelligent vision systems, pattern recognition, object positioning. So they can actually help pick up material and help identify, alignment of material and so on and so forth. But they are also safe. So when I say safe, they actually comply with safety requirements. And for many applications, they may not even actually need a fence. So in these applications, they can actually work together with humans, side by side. Okay, and of course, they are scalable and flexible, so they can be deployed for multiple operations, and they are simple. They can be easily programmed using a graphic-based user interface. Similarly, if we talk about AMRs, which are the autonomous mobile robots, these can assist in material movement because they are self-mapping and self-navigation. So they are natural feature navigation, which means basically they don't need magnetic tapes. They don't need a fixed path to move on. They can move on, find their own path in a given factory floor, even when it is actually the position of dynamic objects is, changing on the factory floor. Maybe somebody is keeping some material or something on the path. It will find a way around it. Then we have fleet management. So basically, this is like a software which allows multiple of these devices to work together in a configuration. They can work collaboratively with each other. They are easy to deploy, and also there is a very short installation time, and we really don't need any facility modifications. So this is how AMRs can actually assist in material movement while working with humans. Okay, the next two challenges about unreliable availability of skilled people and uncertain market dynamics that require high flexibility are something that I would like to address together as one group. And so, if we look at it, how can robots help address these specific challenges? That is because robots can be versatile. So if you recall, I spoke about the components in a robot cell. So I spoke about the fact that there is robots, and then of course you need a tooling or a gripper, then you need some sensors and something else to go with it. So if we can actually change so it's robots the same robot can be used for assembly or dispensing or machine tending or palletizing, depending upon really the gripper that is selected here. Okay, so that is how they are adaptable to your needs. So a robot is not something that you buy and then if the need changes, you can't change it. It's like a dead inventory. No, it's not. You can actually reuse it, repurpose it for a different application by investing in a new gripper or maybe building some new sensors or something around it. And then, of course, many times, the tooling itself, the robot can actually change the tooling themselves. There are automatic tool changers available, so they can actually take care of a mix of parts coming in. So the same robot can actually do the screwing, the gluing, and maybe also pick and place afterwards. So you can see here various, kind of tooling end of robot devices here, which can be used to really accomplish high mix, low volume products, and they can work with different machine parts, and work tasks can be automatically taken up. The other factor for achieving high mix, low volume operation is that what if you have two cells, and maybe these two, you are running production on only one cell at a time because of the way the mix is coming. Okay, and this is really likely to happen more and more often. Then what do? A robot can be a fixed device, but actually cobots can really help in this kind of a scenario, because many of these cobots, they come with their own guidance systems, their own precision guidance systems. So actually they can detect their change in position. They can be actually moved around, as you can see in this image where this man is actually pushing a cart with a cobot on it. They can be repositioned to another machine, and using their own inbuilt vision, they can actually recalibrate themselves and decide and start to work on a completely different machine altogether. So let me give you an example of this on the next slide, which is for, let's say, a machine tending application. So if there is a fluctuation on this particular machine, and maybe this machine is not going to be used, this robot or this cobot can actually be wheeled away to another machine and can start to work there almost seamlessly. On the other hand, if there's an error, this cobot can be moved away and the operator comes in. And also, because this comes with kind of a visual or vision integration, the visual positioning reduces the alignment mechanism. So when you move it and bring it back, you don't have to put it precisely to the next millimeter positioning. It can actually realign itself by using the vision. So it can be a little bit of a rough positioning, and it's good to go. And of course, it kind of makes it easy for it to be designed and wired up and all that. So that's how I believe that robotics can actually help enable higher flexibility on the shop floors. Let me move on. I've said enough about the challenges, and I'm really coming to the last part of my presentation here. But I think the most important part of my presentation is about new opportunities. I think it's very, very important to look at that. And I think, as our Prime Minister also said, that the Indian industry should plug into global supply chains. So, how is that going to happen? I think the MSME sector has to take the lead there. And for that, I think the focus has to be clearly on quality, consistency, reliability, and hygiene. Hygiene, especially now in the current scenario, and especially when it comes to food articles. So, how do you achieve this? So, I think the way to do it is to actually look at, to have a vision of achieving reliability, quality, and traceability. And this vision can actually come from the fact that when you have this vision, you got to see the robot not just as a standalone device, but start to look at the system that goes with it. It could be the vision systems, it could be the PLCs that go with it, it could be the rest of the sensors, the HMIs, and everything else that can go with it. So this kind of devices, an integration that comes to the shop floor or comes to the cell, is something that can help deliver reliability, quality, and most importantly, traceability. More and more customers, more and more OEMs, more and more end users are today asking for traceability. They want to understand where and what went into these parts. And I think an integrated solution based around the robots can actually help build this traceability. The last aspect that I want to touch base is about hygiene. So of course, there's a huge potential for India to get into food, primary and both primary and secondary packaging. But I think the demand from customers is really going to be about hygiene. They are really going to talk about, okay, how many people have touched this food that I'm planning to eat now, or is they're going to prefer something which has not been touched by anybody. And I think again, robots are to the rescue here. They can be used for picking up semi-finished or naked food products. Plus, they can be used for secondary packaging of boxing of finished products, etc. Of course, when you are going to use a robot or any device for naked food, it has to be important that the robot can be washed down. You can wash it down, you can clean it up. So I think this is something that is also we can something that can be achieved with the robots. Okay, as I move forward, I want to just kind of give a kind of a summary slide about the benefits of using robots. One is the accuracy, very important. You get consistent, you get complete accuracy when you're using a robot, especially for assembly. There is no, it reduces the need for post-production quality checks. Then consistency. Again, this is not, now you are no longer dependent on the skill of the operator. You are no longer dependent on worrying about the quality of the night shift versus the day shift, the A shift versus the B shift. No matter what shift, no matter who the operator, it's not important at all, because the same robot works in the same fashion to give a consistent product. Of course, audit trail, which is similar to traceability that I spoke about. Productivity. I think this is another important aspect for the Indian industry. And I think many of us are aware that Indian industry is not really one of the high productive industries in the world from a global point of view. But I think here, by freeing up manual resources for more value-added tasks, robots can help improve productivity. And of course, elasticity and flexibility. So robots can help deal with spikes and troughs in demand, because they can be repurposed, because they can be retrained more easily than humans. It's easily impossible for them to shift to another machine. They don't demand an extra bonus or something. So it's far easier. They are good enablers to flexibility. And then, of course, staff retention. We have seen many times that the staff retention becomes a challenge because people don't like to do routine stuff. So robots take away the monotonous jobs, they take away the routine jobs, just picking and putting things in a box, for example, and then allow the human potential to actually work towards more stimulating, more creative tasks, which robots are not good at. Then, of course, reliability. I think this is self-explanatory. They don't take off. They don't get infected by coronavirus or whatever. They don't need a mask also. And of course, ride sharing. I think from a geographical point of view, more and more, as I mentioned earlier, that the supply chains are likely to relocate. They're likely to reshift and realign. And I think this is where more customers are going to look for consistency. They're going to, before they offload an order, they want to understand, are you going to be able to deliver what you're saying, or are you going to be able to deliver as promised? And I think the answer to that must come by using robots. I think that is one easy answer for that to happen, because anything that is people dependent is likely to have an element of uncertainty to it now, especially now. And of course, the last part, that basically robotics is a low risk, non invasive technology. You don't have to, kind of dismantle your existing setup to put a robot. It's an add on. It can come on as is, come onto your shop floor as is, and start adding value. Okay, with very little modification. Of course, some modification will be required. You might have to put a gravity conveyor, or you might have to put a some other kind of a conveyor or sensors. But yeah, it's a minimal thing. You don't have to kind of throw away your existing machine and get a new one. And I think that's also why, and this technology that is developing so rapidly, that the actual affordability of robotics is going up far higher today than it was ever before. So with that, I would like to actually run an audience poll, and I don't know, can I request Mr. Wadhwa to run the audience poll for me, because I'm not so very familiar with the system. Yeah.
Sure. So, poll is on.
Yeah. So I would really request and urge all the audience members here to vote. We want to try and understand what do you think are your likely scenarios, or what do you think is likely to happen in this post-COVID world as far as robotics is concerned. So, of course, I believe FSM will keep this data confidential, and it is anyway anonymous. So, happy to see a lot of votes already. So maybe we can just give a few more, half a minute or so.
Sure. Also, Mr. Gandhi, there are 4 or 5 important questions coming from the audience for you.
Yeah.
So once we get Dr. Jha to finish his comments, you could have a look at it, and then I'll call you back to answer those questions.
Sure. It'll be a pleasure. So maybe we can, I think we have got about 36 votes in, and I think I can show this result here on to the attendees. Some more coming in, but yeah, thank you for what we have. But so it's a very interesting result. So I just want to show this to the attendees.
Yeah.
So the answer was, do you think adopting robotics on your shop floor helps to achieve your business goal in the current scenario? And if you can see, there is nobody who said a no, which is great. Of course, we need to understand more. Gets about 64% of the votes. 37% of the people say yes, definitely. But what is very heartening to see is zero for no, which is absolutely great. So thank you so much. You can keep voting for some more time, I guess. That will help us analyze the results. So I'm going to hide this now and move back to my presentation and basically close the presentation. Happy to take your questions, and of course you can see the 2 email IDs on your screen. Please feel free to write back to us and we would be happy to respond to any questions or comments or suggestions or requests that anybody in the audience might have. Thank you so much. And Mr. Jha, Mr. Wadhwa, back to you for this.
That was really wonderful, Mr. Gandhi. And again, really, really opening up the mind to so many possibilities for the shop floor. Now, what you've shown really is something I know Dr. Jha has been researching all these areas of cobotics and autonomous vehicles, smart sensors, etc. The real challenge, I guess, is not only the cost, but also an issue related to competencies, not at the end of companies like Omron, but at the end of the user and the integrator. Dr. Jha, what competencies really, an organization needs to have to evaluate, to implement and maintain these smart devices? Can you throw some light on that?
Yeah, I think that's what Samir has mentioned, that the exciting part is that no one want to avoid the robots. Everybody is interested to work with the robots, and they are keen to have such high-tech equipments in their facility. The most important part, the other part of the results reflect back that majority wants to know more about these robots and cobots and the new technologies. And I think the most important part, though Samir has covered a little bit more about the additional elements required along with the robotic hardware as a gripper, a sensor, and how it will be integrated into the facility and the control system. The most important part to know about robot, and even before you think about deploying the robots, how you plan your facility along with the robots. So basic learning and even the skilling in terms of operating and programming a robot is required. Even to a certain extent, the engineering design part is also required, means how you are going to put. So as I was responding to some of the question also, robot is ultimately a mechanical manipulator. So wherever we see there is a need of an operation where you need a mechanical manipulation, certainly the robot is one device which is easily available to deploy with. But at the same time, we can do more brainstorming. So because we always worried about the cost of the robots and the robotic integration into the facility, but the area of engineering research is always open to develop the low-cost manipulators. And I think many companies are working in India as well to build the indigenous robots, so to bring out the cost down. But other than that, we are always worried about replacing human being by the robots. So I don't see that's a problem today, because if you replace one person and put a robot there, you need 3 more person to basically run the facility with the robots. So you need people to understand the robotic integration. You need people to do the programming of the robots and then controlling the facility. Certainly, it requires an upskilling. You may not be able to deploy the same person whom you are going to replace with the robot, but you will be adding more manpower at least. So and even at a little higher end. So it requires more learning and upskilling of the people. So robots is certainly a good opportunity, and in the kind of a scenario that has been mentioned. And there are many basic courses. It doesn't require that you need to go for a specialization in robotics to operate a robot. Even a short-term courses, maybe the 6-7 days of learning or a little bit on hands-on, will give you that exposure and understanding of the whole technology, how it can be integrated into your facility. So I think that's what we look forward, because if you have an interest and zeal to go with the robotics, I think we will be able to provide those platforms to get you familiarity with the technology, and then maybe do experiment with our help, and then later you can plan for deployment. Over to you, Anup.
Yeah, that's really nice. And I think at this point, I'd also like to mention that AIA and IIT are putting together some joint programs in terms of training programs. And that is now being launched. Currently, we are doing it selectively for institutions. But I think the time is not far when we'll be opening it for individuals as well. So all of you who are interested in training programs should write into us. You have our emails. You have my phone number where you can WhatsApp. I would now move to the last section, which is the Q&A section. So I'm going to ask 3 questions from Mr. Gandhi. These questions have already come in from the audience. But I would also like the audience to go back to the initial talk by Ms. Balakrishnan and pose your questions for her to answer. So let me begin with the first question for Mr. Gandhi. One is on cobot or robot. Can they be used for bagging operations in the urea plant? That's being asked by one attendee. While you answer this, I'll take out your next question.
Okay. Yeah, I think we need to kind of understand in more detail what the operation is. But typically, yes, it can be used. By bagging, if you mean, are we going to be able to lift large bags and put them on pallets? Yes, definitely robots can do that. Please bear in mind that what really determines this is the payload capacity of the robots. While robots can have a very high payload capacity, sometimes even going up to 100 kgs or so, cobots so far have a payload capacity of about 14 kgs or so. That's the industry norm that we currently have. Okay, so you need to kind of talk to some system integrator or supplier to kind of understand, who can come down and understand more about the process and the operation, and then maybe suggest the best technology for you or best solution for you. I hope I answered that question.
Yes. And I think the role of integrators and the role of automation consultants is also going to ramp up considerably, because there are going to be all these missing pieces, and it's important for users to get a sense of how to plug in all those links. The second question coming is, why can't we have remote joystick devices for machine operations similar to the operations of mobile machines? This will help the operators to be in control of the machine as well as deliver or secure from remote place. Okay, so I don't know what the question really is. Is it about the device on the machine, or are you really talking from working from far away distance, which is really work from home for an operator? Maybe you'd like to address both, Mr. Gandhi.
Okay. Okay, this is a tough one because I think working from home, yeah, of course, technologies are available. Can they be used or adopted to an industrial environment is something that we need to see. I mean, the immediate example that comes to my mind for working from home is, for example, drones. Especially the U.S. Army, and you've probably seen it in a lot of Hollywood movies. They have all these kind of drones that are flying around all over, different countries, hunting down terrorists or whatever. And they are being flown by pilots who are actually sitting somewhere in the U.S. in a box. Yeah, I think that's a good example of kind of remote working. But can this be adopted to the industry? Yeah, I guess so, yes. At least I'm not aware of any immediate kind of solution that is available for this. I don't know how can that be done. Then the other question part was about having joysticks. I think joysticks is on devices and machines is fairly common today. I mean, there are many things that use joysticks. Crane operators, for example, use joysticks on a regular basis. People, who are moving material, sometimes on shop floors, they use joysticks. So I think that's kind of fairly common available device. Yeah, and can be integrated with machines as well, I guess. It depends really on the application and what you want to achieve from there.
Okay, great. So that's I asked you two questions in one. So now I'm going to turn back to Uma. But meanwhile, we've had one of the automation champions I've known for long, Mr. Vivek Gupta from Kota. He's responding to the question on the bagging, and he's saying the solution could also be a combination of robot along with linear positioners. So that's an interesting observation.
Yeah, definitely. Yeah, it's not always that you need to have a standalone robot for every solution.
Yes, yes.
We-
Now, Uma, the question for you is on production visibility. While production visibility is important, there are challenges with legacy infrastructure. Can you share your views to overcome such challenges? A question asked by Mr. Rajkumar.
Uh, can you hear me, Anup?
Yes, yes.
Yeah. So the two parts to that, I think the legacy, when we say legacy infrastructure, what happens when you look at visibility is depending on the age of the plant or age of the line in a production floor. If you should take, we buy machines at different times, so or lines at different times. So whatever was the technology or whatever was the budget at that time, it's bought. Might be I can I'll give you a simple thumb rule for how, but we work extensively on how we smartly do that as a business. So you could email to uma@accent.com and I can have one of my colleagues sort of share more details. But for the audience in general, the two ways to address the legacy infrastructure. So we actually follow this method, which is we make a checklist, which basically looks at the process, what is getting done, and we look at that what is the equipments available on that, and then we put it as manual, auto. In auto we have it as mini, three segments of it, whether it's an auto which is very basic, which means you have a HMI or a small panel. So we have some classification, so based on which the entire process is mapped. And then we do an analogy to say, okay, in this, which are the critical information which is needed for visibility, which we work with the user to understand it, cross-reference it, and then say, how do we do? So we don't get into typical issues which come in legacy infrastructure is, I have this machine, the port is closed or the OEM has locked it or it doesn't have data. I think the way to address that would be to simplify the data and say, I just want to know if it's running or not. I don't want to get too much information. That's a start. So there's different ways of skinning the puzzle there. There is a structured way of doing it, and it is not a solution in complete that you can just see everything, but I think it gives you the first phase. Then other thing we recommend is we tell them, and which is a challenge in organizations, because their procurement, when they're ordering a new machine, as we are discussing legacy machines, somebody in the facility is ordering a new machine somewhere for doing something. So we advise to have a strategy, but say whenever they buy any equipments or whatever they do, what are the minimum prerequisites which should be open and connected, open and available. If you can, when you're buying, your purchasing power is higher. So if you can insist to get open systems in place when you're buying new, as you're doing this, and have a strategy for old ones to adapt. And some of them, if the life of the machine is gone and anyway something is planned to be upgraded, there's no point in investing in it. So you need to make I would use Anup's word, we would need to take a business common sense approach and map it and then adopt the technology. The challenge there will be you will have to use 2-3 gateways, 2-3 different kind of technologies, but still it's worth the efforts to do it. You could drop a mail or write to EIA, and we can get into more specifics on that, but there's a method to approach it.
Okay, sure. So that ends our session today. We've closed with two really interesting aspects of automation. One is from the information side and the other is from the material movement side. That's really the blend of cyber and physical, which is emerging fast. So we will surely be bringing more and more of those topics where convergence really matters. Now, I would like the audience to really look at the next 2 dates of our webinars. The one on 29th May is being done jointly with the Engineering Export Promotion Council, and it's going to be targeted specifically at the smaller and medium-sized businesses. And then we'll come back with more of the high-end applications, and that will be on the 12th of June. Meanwhile, you are free and most welcome to send in your requirements of technology. What are the solutions you're looking for? Because really this webinar series is for you, the audience, and we would love to respond to your requests. Thank you once again, our panelists, Oma Balakrishnan, Samir Gandhi, Professor Sunil Jha, and also my gratitude to all the staff members of AIA and the foundation who have helped behind the scenes. You really made this count. And once again, lots and lots of thanks to all our attendees. Your thirst and passion really bring us forward to bring you these webinars. With that, I'd like to close. Stay safe, stay secure, and stay smart.
Thanks, Anup. Thanks, everybody.
Thank you.
Thank you, everybody.